Alright, so we're coming up into our last couple of videos here, and we're going into section 5, where we're actually going to look at the process of how to balance and determine the oxidation state of a compound or of elements in a compound for an oxidation reduction reaction. Now, for a redox reaction, we have a couple of things that we're going to need to pay attention to. So again, take notes, and if you have questions, please don't hesitate to ask me in class. Now, what is an oxidation reduction reaction? It is a reaction in which one or more electrons are transferred. These are going to usually fit into or have these types of equations fit into it. Synthesis, decomposition, single replacement, combustion. These are going to be those where we'll actually get a chance to see how the bonding sort of occurs and the quote-unquote charge or oxidation state of the element will change from the beginning of the reaction to the end. Now, this is one example that we want to look at. For sodium metal, at the beginning, it's an element, as well as chlorine. They usually have an oxidation state of 0. And we're going to get to how we determine that in just a moment with the rules. But by the end, we're noticing that sodium has a charge of +1, or an oxidation state of +1, where chlorine has one of -1. How do we have that? How did this take place? And we're actually looking at the fact that we have the transfer of a lot of energy as well as that electron. Now, how do we actually determine the oxidation states, or how do we assign them? First thing we're going to look at, if it's an element, meaning a diatomic element, or just a regular element directly from the periodic table, it's going to have an oxidation state of 0. When we look at the oxidation state for a monatomic ion, that means like your chloride ion or your sodium ion or magnesium ion or fluoride ion, either of those, you're going to go based on the charge of the actual ion. Oxygen, when we're dealing with covalent compounds, is going to have a charge of -2, except for, and again, got this note here, except in peroxides, where you're going to see -1. That's where you're usually going to see a compound, say like hydrogen peroxide, H2O2. This is a peroxide group, and so it actually has a charge or oxidation state of -1. But just keep that in mind. Hydrogen always has a charge of +1 in covalent compounds. So that's going to be in your ions, it's going to be in your acids, whatever the case may be. We're going to be dealing with hydrogen with a +1 oxidation state. Fluorine, -1. Now, in the end, the couple of things we want to make sure is that the sum of all oxidation states equal out to 0. So, depending on that, sometimes you may have one like carbon will have a range of +4 to -4. Sometimes it'll be positive, sometimes it'll be negative, but it all depends on how many are there and what role it's actually playing. Now, to get a little bit of extra practice with this, you may want to go ahead to, again, and go back to your Mahjong Chem. It actually has some practice where you can go through and play Mahjong, which is calming, but at the same time you're practicing learning oxidation states and predicting the oxidation state based on the compound. So, last but not least, the sum of the oxidation states should equal the charge of the ions in the compound. I think I had a little typo there at the end, and I apologize for that. But we continue on. These are, again, something you need to memorize and have in mind. Now, how do we know which is happening? How do I know if it's oxidation or reduction? Well, we have a couple of things that are going on. Oxidation loses electrons, so we're going to see an increase in oxidation state, or it's going to become more positive. Reduction is going to gain electrons. Decrease in oxidation state will become more negative. A couple of things we use to remember this is we say Leo the lion goes Gur. Lose electrons, oxidation, Leo, and Gur, gain electrons, reduction. Another one that is used many times, and whichever one works best for you to remember, I prefer that you go ahead and use it. It's just oil rig. Oxidation is loss, reduction is gain. Again, just a couple of things to try to keep it in your mind and make sure that you retain this information, because we're going to use it throughout the rest of the year. Now, when we work on balancing, the only method that we're going to worry about at this time is we're going to deal with the actual change in oxidation state. So the first thing we have to do is write the unbalanced equation. Once we've done this, we determine the oxidation states for each of the atoms in the reactants and the products, so we can see which ones have gained, which ones have lost. We're going to show the electrons gained and lost by using tie lines, or basically as we see the where they are, we may say here and tie a line to it so we can see directly where it changed to. Use coefficients to equalize the electrons gained and lost, balance the rest of the equation by inspection, and then add the appropriate states, most of which we will have done without too much of a problem. We're going to do, of course, some more practice with this, so do not fear. Now, looking at the example that we have here, it's just a little practice. We want to balance the equation between solid zinc and aqueous hydrochloric acid. It's going to produce aqueous zinc 2 chloride or zinc chloride and hydrogen gas. So if we're looking at zinc in the beginning, zinc actually has an oxidation state of, you got it, 0, because it's an element, it's in its elemental state. Whereas the hydrogen here has a charge of +1 and chlorine -1. So that's why it would equal out to 0. +1 minus 1 gives us 0. Now, on the other side, we notice that zinc has a charge of +2. Ooh, it's changed. Chlorine still has a -1, but now the hydrogen has a 0 charge. Why? Because, again, it's in its elemental form. It's a diatomic. So that means it's going to have 0. So what was reduced? What was oxidized? Well, let's see. If I have my zinc here, it went from 0 to -2. +2. That means that it had to lose electrons. So zinc was oxidized. Whereas if I can change my color real quickly, now as I'm looking at what was reduced, well, I want to look at what I had before and after. Chlorine stayed the same, so that's the spectator, but hydrogen went from a +1 to, on this side, 0. So that means it had to gain an electron. Since it gained an electron, it was reduced. Now I realize this looks a little chaotic right now, but we're going to do a lot more practice with this so you get a chance to see how things are going. Now if we were to look at and balance this, we now know that we're going to need 2 chlorine ions or 2 chloride ions here. It's going to help us to balance there, which means we have to balance this here with the 2 chloride ions. Everything else should be fine. So this reaction is balanced. Looks a little chaotic, but again, we can clean it up in just a moment. Now, that's where we're going to end off for today. Again, stay tuned for, I'm going to put some other videos up of some practice where we're running through a couple more examples so you guys can get used to and see what it is we're going to be dealing with. Have a great evening, and I look forward to seeing you in class. Goodbye.